Hey everyone, thanks for tuning into our talk on modern C++ development in Visual Studio. I'm Nick Uhlenhoot and I'm here with Erica Sweet, and we're both program managers on the Visual Studio team for C++. Here's a look at our agenda for the day. I'm going to be covering the first half of this, then I'm going to pass it on to Erica, and then we're going to go into two awesome demos at the end of the talk. So with that being said, I'll dive right into the first bullet point here, and that's conformance. So just a reminder, MSVC has C++17 conformance. Additionally, we've added full support for a conformant C++ preprocessor, and that's behind a ZC preprocessor switch. In addition to standard conformance, we've also added support for C++20's VA OPT, and to enable this, you just need to add the ZC preprocessor to your compilation flags. If you are using older code, don't worry, the legacy preprocessor is not going anywhere, and it will continue to serve as a compatibility layer. Speaking of conformance, let's talk about C++20 conformance. We aren't there yet. We have a lot of work to do for C++20, but we're very committed to getting there as soon as possible. For now, let's talk about concepts and modules. Concepts are already supported in MSVC, in our STL, and we have recent IDE support in the way of quick info and member list, which I have images of on this slide. With modules, we've actually recently added quite a few MSVC improvements, and I have those listed on the slide. We've added header unit, context-sensitive module and import keywords, global module fragment, and support for module partitions. To use this support for modules, you will need to enable a few different switches, which we have detailed in our blogs and documentation, but the main one that you'll need to know is experimental module. Now, speaking of language conformance, let's talk about the STL. Microsoft's implementation of the standard library is now open source. You can go to that GitHub link that I've posted here, and all of our development happens through GitHub issues and pull requests now. It's designed for the MSVC toolset, and it works with the MSVC compiler chain, and it also supports Clang and the EDG compiler. We've completed C++17 support. We're C++17 complete, and here are the C++20 highlights that we've recently added on this slide here. Now, I've listed a few of these highlights, but we definitely need your help, so keep giving us your pull requests and submitting them on GitHub. But Nick, what about my builds? I'm glad you asked. We've done quite a bit to improve your build experience. For example, we've greatly improved our linker. You'll notice that when compared to Visual Studio version 15.9, you'll see anywhere from a 3x to 10x improvement in your link time for debug full in Visual Studio version 16.6. Additionally, for debug fastlink, you'll see around a 2x improvement. And to do this, we had to improve our core data structure and algorithm implementations. We've also given you the ability to analyze your builds and get build insights better than ever before. So that's with our C++ Build Insights tool. We can see it in action here. This provides visibility into the MSVC toolchain, and it answers things like, what is my compiler doing? Are my builds sufficiently parallelized? Is there a bottleneck? What should be in my PCH, and more. It combines with the ETW, Event Tracing for Windows, to make timing information of the C++ toolchain more accessible than ever before. You'll need two things to enable the power that we're seeing here, and that is the Windows Performance Analyzer, and you'll need to run vcperf from a developer command prompt for Visual Studio 2019. Lastly, it's got an SDK, which you can control this analysis programmatically. You can download that SDK as a NuGet package from within Visual Studio, and it has a collection of APIs that allow you to create personalized tools on top of the C++ Build Insights platform. We've also recently added some inliner improvements that will improve your runtime perf, but they also have some throughput benefits. We've added the ability to inline some routines after they've been optimized. So depending on your app, you could see a lot of compiler throughput improvements, which means shorter build times. For one example, modules that have heavy usage of the eigen library should see a lot of throughput improvement. Lastly, let me talk about IncrediBuild. IncrediBuild ships as an extension in Visual Studio 2019, and they give you a free license to accelerate your build on your local cores. You can also use their build monitor to analyze your build from within the IDE, so if you haven't checked it out, definitely do that. Now I'm going to pass it on to Erica, who's going to talk a bit about security.
Thanks, Nick. So my name is Erica. I also work on Microsoft's Visual C++ team, and I'm going to start by covering some security improvements that we've recently added to help you write more secure code. So up first, Address Sanitizer, or ASAN, is a runtime memory error detector for C and C++ that used to be native to Linux and Mac OS until we recently ported it over to Windows to be used with the MSVC toolset as well. And this experimental support was initially announced at CPPCon in September. Until now, you could only use ASAN with your 32-bit release configurations, but we hear your feedback, and you can now use ASAN with your 64-bit targets in Visual Studio, as well as with the debug versions of the runtime library. And this is all available in Visual Studio 2019 version 16.7. So please continue giving us your feedback. We are eager to improve this feature, as the next step is to take it out of experimental. About a year and a half ago, we added a new compiler switch, QSpectre, to protect against a new class of vulnerabilities called Spectre attacks. And QSpectre only protects against variant 1 of Spectre attacks, which is bounds check bypass. We recently added 2 new switches to provide a more complete mitigation of variant 1 of Spectre attacks, QSpectre Load and QSpectre Load CF. And all of these compiler switches can be enabled under the code generation section of the property pages, and they're available in the toolset release associated with Visual Studio 2019 version 16.5 and in supported releases. We also have several new improvements under the umbrella of code analysis. So code analysis is the static analysis tool that can check for possible defects in your C and C++ source code that can be run from the command line and is integrated with Visual Studio. So we recently added 2 new checks related to use after move and coroutines, as well as a brand new IntelliSense code linter that's faster than background code analysis that I'll be showing a bit more in my demo. Microsoft's implementation of the Guideline Support Library, or GSL, contains functions and types that are suggested by the C++ core guidelines, and the latest release, 3.0, contains new implementations of span and span iterator that align with C++ 20 standards, changes to contract violation behavior, as well as CMake support via the find package command. Finally, in the past year, we also added native support for Clang Tidy, which is a Clang-based linter tool developed by LLVM that we've added as a part of our out-of-the-box support for Clang. Up next, a quick update on C++ CLI. So C++ CLI provides easy interop between native C++ code and .NET technologies like WPF and Windows Forms. And if you were previously using C++ CLI with the .NET Framework, you can now take advantage of all of the new features that are a part of .NET Core with .NET Core 3.1 or later, and that corresponds to Visual Studio 2019 version 16.4. To get started with C++ CLI and .NET Core, you can either bring existing C++ CLI code to an empty project or retarget an existing project to .NET Core, and instructions for both of these workflows are available on the C++ team blog. VC Package is our cross-platform open source library manager for C and C++, and we recently published a public-facing roadmap for VC Package. We will also be sharing all of our specs for upcoming features to the VC Package Wiki, so please check out those resources and offer your feedback, as we're eager to keep improving this tool and make it the best library manager for you. Just to cover a few highlights of the new public-facing roadmap. Right now, you can only bring down and build libraries locally, but we'll be adding support for binary caching and remote hosting services to improve the speed of acquisition, as well as allow developers access to the exact same binaries. You'll be able to specify which version of a library that you want to install. You'll have a first-class experience using your privately hosted libraries with VC Package, in addition to all of the libraries that are available on the open source catalog. We'll be adding support for a declarative manifest file that can be checked into source control and consumed by VC Package, as well as better support in both Visual Studio and Visual Studio Code. Finally, a quick update on our CMake and cross-platform support. So CMake, if you're not familiar with it, is a cross-platform open source meta build system, and it is our recommendation for anything cross-platform or with an eye to open sourcing. Native support for CMake and Visual Studio means that you can open any folder containing a cmakelist.txt file and edit it, build it, and debug it either locally on Windows, on a remote system that's connected over SSH, or natively on WSL without ever generating Visual Studio project and solution files. And I'll be showing you what's new with our CMake support as a part of my demo. CMake is our recommendation for anything cross-platform, but if you're not writing cross-platform code, or if you just don't want to use CMake, then we also have support for MS Build-based Linux projects. And our cross-platform support is an area that we continue to invest in, and some of the new features that have been added in the past releases include first-class support for GDB server, streamlined debugging templates for remote debugging with CMake projects, Ninja support on Linux, and some improvements to our remote IntelliSense, which provides IntelliSense as if you were working natively on your remote system. So with that, I'm just going to hop right on into a demo where I show you some productivity features and give an update on our CMake and cross-platform support in Visual Studio. So here I have a CMake project open in Visual Studio. The project that I'm working with is a cross-platform Qt widget, so I'll start by running it locally on Windows to show you how it works. The project is an open source Markdown editor, so I can do things like set headers, search, things like that. CMake projects in Visual Studio look and feel pretty similar to Visual Studio Solutions with a few key differences. So here I have a few CMake configurations that are defined in CMake settings. CMake settings is where you can configure CMake invocation and build, and I'm going to spend just a few minutes walking through it in case you are familiar with Visual Studio but new to CMake development, familiar with CMake but new to Visual Studio, or new to both technologies. So this CMake settings editor is an editor on top of an underlying CMake settings.json file that can be checked into source control so that you only need to do this project-specific CMake configuration once. You can define where your project will build with a configuration, and that can be locally on Windows, on a remote system connected over SSH, or natively on WSL. You can also configure how your project will build, so you can do things like set environment variables, CMake variables, and pick your compilers. So right now I'm editing my x64 debug configuration, and when building locally on Windows, we have out-of-the-box support for both MSVC and ClingCL. We also have support for CMake toolchain files, which is the recommended method for configuring more complex build scenarios, like picking your own custom compilers or cross-compilation. You can pass command arguments to CMake or directly to the underlying build system. When building on Windows, we have support for the Visual Studio Generator and Ninja. And when building on Linux, we have support for Unix makefiles and, as of recently, Ninja. You can also edit the CMake variables that are persisted in the CMake cache. So if you're familiar with the CMake GUI, this offers fairly similar functionality. The only edits that I needed to make to this configuration to build this Qt widget locally on Windows was set CMake prefix path to the path to the required Qt modules that are used for CMake generation and build. If you use either a custom build script or an external build tool to invoke CMake that's more than just a thin wrapper and can't be encoded in a single CMake configuration, then we also have support for opening an existing cache in Visual Studio, which will give your preferred build tools complete control over the CMake cache and build tree. Now, if you take a look over at the Solution Explorer, you can see that right now the layout of my files mirrors the layout of my files on disk. But we also have support for CMake Targets View, which is a more CMake-centric way of viewing your code, organized by target, and especially if you're working with larger projects, can make it easier for you to understand and navigate the structure of your code. So I'm going to hop on over to my root CMake list, which, if you're familiar with Visual Studio projects, is most similar to the VCX proj file. And you can see that I'm passing a few variables around, and let's assume that I didn't know the value of this source files variable. We've recently added language services for CMake, so I could right-click Peak Definition and see those source files enumerated for me. And I realize this isn't the most exciting example because this project only has one CMake script, and so source files is set in this same file. But language services for CMake works for any CMake script in the scope of the project. So if you're working with a really large code base that has multiple CMake lists spread across multiple subdirectories, then language services for CMake can be used to better make sense of, edit, and author your CMake scripts right in Visual Studio. We've also recently added project manipulation support for CMake projects. So let's pretend that I want to add a new source file. Add new item. We'll call it source.cpp. Then instead of just dropping that file on disk, Visual Studio will try to understand where I can edit my CMake scripts to add a reference to that newly added source file. And this is what VCX proj does automatically behind the scenes. But because there's a million different ways that you can author your CMake script, when there's any ambiguity, Visual Studio will prompt you with multiple ways that the edits can be made, and you can select only the ones that make sense for you. And finally, if I hover over commands like find package, you can see that I'm getting quick info. I'll also get IntelliSense completion suggestions and tooltips. And this is all part of the CMake in-editor documentation that we added that surfaces official CMake documentation right in the IDE to save you time switching context between your code and looking up CMake docs. So far I've just been making edits to my CMake script, but now I want to make a few changes to a source file. So I'll open up this CPP file, use Control-G to go to line 93, and here I want to add a new comment that describes this set highlighting enabled function, what it does, and its parameters. So we've recently added automatic stub generation for comments that supports XML doc comments and Doxygen. So I can add a summary of this function. So this just enables or disables markdown highlighting, as well as descriptions for individual parameters. So this bool enabled just enables or disables highlighting. Now these artifacts will surface in tooltips or in quick info. So for example, if I hover over enabled, then I can see both the description of my function as well as the description of the enabled parameter. In this file, you can see that I'm also seeing a few warnings, which is indicated by these green squares in the scroll bar. So I'm going to scroll down to the one that's right below me and see if I can figure out what's going on. So here it's saying, hey, you're using a bitwise operator when a logical operator was probably intended, and this is a logical bitwise mismatch. So I can take a look at the suggestion. You can see that the warning is prefixed with L and T, which shows that it's coming from the new IntelliSense code linters. And the suggestion is just to use the double and instead of the single and. So if I agree with the suggestion and I want to incorporate these changes, then I can just click on it and the edits will automatically be made. And these new IntelliSense code linters work really well in conjunction with background code analysis because the linters are super fast and catch easy to detect errors as you type, whereas background code analysis is good for more complex analysis. So far, I have only been running this project on Windows, but one of the main value props of CMake is that it is cross-platform. So now I'm going to show you how quick and easy it is to retarget the same project for Linux. So I'm going to go back to my CMake settings editor where I already have a Linux configuration defined. I'll go ahead and make it my active configuration. So that generation will start. And one thing that I want to call out while this is generating is that the remote header sync that Visual Studio does automatically to copy your headers from your Linux system to Windows for a native IntelliSense experience has been improved so that it is no longer a blocking operation and now happens on demand and in the background. All right, so it looks like that's done. I'm now going to show you how I configure debugging on my remote system. So I'll select my active CMake target, go to debug and launch settings. And this opens launch.vs.json, which is the JSON file that's used to configure all debugging sessions for CMake projects. Based on your feedback, we've tried to make it a lot easier to configure remote debugging. So we've added this new CPP GDB template that's used to configure debugging with GDB and GDB server that's been streamlined, as well as adding first-class support for GDB server. So right now I'm using GDB, but if I wanted to debug with GDB server, all I would need to do is change this key value to GDB server, and Visual Studio would pass a new set of default values and manage that GDB server process for me on my remote system. So the only changes that I needed to make to get this debugging on Linux was to 1, export my display variable, and 2, set LD library path to the path to the libraries that Qt requires at runtime. So with that, I'm ready to start debugging on my Linux system. I'm using a Linux VM that's running locally. I'm using Ubuntu. So I'll go ahead and pull that up. And here you can see I have the exact same application that's building using the same source files and the same build scripts, but on Linux. So I'll stop this, head back to Visual Studio. All right, so the last feature that I want to show you guys today is something that we call the separation of build and debug, which is the ability to separate the system that you are building on from the system that you are deploying to and debugging on. And the scenario that I'm going to cover today is I'm going to build locally on WSL using our native support, but I'm going to continue deploying to and debugging on my Linux VM so that I can leverage its GUI support. So as I mentioned earlier, build is configured in CMake settings. So the only thing I need to do to start building natively on WSL is make my WSL configuration active. And by default, the system that you are building on is synchronized with the system that you are debugging on. So if you want to separate those, then you need to explicitly specify a new key in your launch file. That's this remote machine name. And the value of this key is where Visual Studio will deploy to and start debugging on. So when I start debugging this, just to recap, I will be building on WSL and deploying to and debugging on my Linux VM over SSH. And real quick while this is working, when we say native support for WSL, what we mean is that there's just one single copy of your source files and no dependency on SSH. And so there's no need for Visual Studio to manage file copying. All right, so I'll go back over to my VM. And once again, I see the exact same application, this time building natively on WSL, but debugging on my Linux VM that I am connected to over SSH. So that wraps up the demo portion, and I'm going to head back over to the slides. So the biggest takeaway from this demo is to try Visual Studio's native support for CMake if you are interested in cross-platform development. We covered some CMake specific features like language services or project manipulation support that can help make your life easier if you're trying to make sense of, edit, or author CMake scripts in Visual Studio. We covered some productivity features like code analysis that work whether you are targeting Windows, a remote system, or WSL. We also covered some cross-platform features like the ability to separate the system you are building on from the system that you are debugging on. And in this demo, I was using WSL1. One productivity feature that I didn't have time to cover in the demo today is that C++ has support for IntelliCode custom models, which means that you can train your IntelliCode suggestions over your own repository. Another great option if you're interested in cross-platform development is the C++ extension for Visual Studio Code. VS Code itself is cross-platform and runs natively on Windows, Linux, and Mac OS, and our C++ extension provides a first-class debugging experience on all of those platforms. We also recently became the primary maintainers of the CMake Tools extension for VS Code. There has been a lot of new work on the C++ extension over the past year, and some highlights include refactoring capabilities like find all refs and rename, multi-root support for both the C++ extension and the CMake Tools extension, as well as some brand new features like code folding and IntelliSense modes for Linux on ARM or ARM64. And with that, I'm going to hand this back over to Nick, who's going to be chatting with you guys about Visual Studio Codespaces.
Okay, I'm going to show you a demo of Visual Studio's awesome new support for Visual Studio Codespaces. Codespaces are managed development environments in the cloud, and you can connect to these codespaces from Visual Studio, VS Code, or even from our editor in the browser. So this greatly expands the devices and places that you can code from. A lot of you, like me, are probably coding from home now, and you may be on a laptop and no longer have all that horsepower of your office machine. However, the beauty of these Visual Studio Codespaces is that your environment is in the cloud, so you can connect from your laptop but get the power of cloud compute. But I know that seeing is believing, so I think it's time to swing over into a demo, and I'll be connecting to my codespace using Visual Studio. I've opened up Visual Studio 2019, and this should look familiar to you, except I do have this new tab here to connect to a codespace. So I'll go ahead and click that, and now it's loading up my plan. This is my billable entity, and I've already created 3 different codespaces here. If I wanted to add another one, I can just click New, give it a name, point it to a Git repository, choose what sort of cloud compute horsepower I want to have, and then I can choose what sort of suspend time I want once my code space goes idle. Then, when you click Create, your code will be cloned and your environment will get configured for you to quickly onboard and get coding. But I've already done this for my fork of OpenCV, so let's go ahead and connect to that environment. Alright, so now we're establishing our secure and private connection to our code space, and we can see the progress in this pop-up. You'll also notice the familiar UI of Visual Studio 2019. However, since we're connected to a code space, my laptop's only responsible for rendering this UI, but all of our other compute is happening in our code space. For example, the Solution Explorer population, later when I go run a build, all of that is happening in my code space, so it's freeing up my local resources. You'll also see up in this top banner here that we have this cloud icon letting me know that I'm connected to this OpenCV code space of mine. As you would expect, you can see all your source code in the Solution Explorer, and I could navigate to a file in there, but I want to show that you also get your Visual Studio navigation tooling with Control-T, and I can limit my search to files and search, for example, for OpenJPEG, and now my search results are only going to show me files, and I can go ahead and click on the relevant CPP file that I want to jump to, and that's been rendered here, and we see the colorization, and we've got some pound includes here. And now let's say maybe I want to do some fancier print formatting. So I want to use printf from the FMT library. So I'll pound include fmt printf.h. And you'll notice we got a red squiggle, and that's because I don't have this library. It says it can't find that source. But also notice that there's a light bulb here, and this is giving me a quick action to help me out. So Visual Studio is giving me this awesome help because I have VC package installed. It knows that it can install the FMT library from there, and I can just click this to copy that command. And now, VC package wasn't originally defined in my codespace, so I installed it and bootstrapped it from within this integrated terminal. This terminal is my access point to my code space. So I'll go ahead and cd into where I installed VC package. So now within here, I can just go ahead and paste that command, and it's going to install the appropriate version of the FMT library for me. You can see it's getting the x64 Windows version in this case. Now, the cool thing about this is that I installed VC package, and even when I suspend this code space and then reconnect, VC package will still be there for me. This is a managed code space for you, and again, this terminal is your access point to that. So it looks like the package installed took about 22 seconds. So now let me go ahead and generate our cache now that we have this new library, so that Visual Studio will now know about it. And then IntelliSense should kick in and this squiggle will hopefully disappear. And as usual, you can click this icon down in the bottom left to see all the tasks that are running right now. So we can see IntelliSense is finishing up. So there we go, the squiggle has disappeared and that error has been taken care of. Now that we've addressed that error, let's go ahead and run a build. But before I build, actually, I just want to reiterate the fact that all the compute-heavy tasks in Visual Studio are running in the code space. So when I run this build, my laptop cores won't be affected. You'll notice right now that our CPU usage is around 20% or so. And so let's go ahead and kick off this build. We're building all of OpenCV. And this compute, again, is happening in the code space rather than on my local machine. So now that this build has started up, I'll open back up my task manager and we can see how our CPU is looking. So it looks like the CPU is hovering still around 19, 20-ish% right here. So this is showing me that I'm no longer bricking my laptop in order to run this build. Instead, my local compute is freed up so I can do other important tasks like play Age of Empires or check my email during this build. Now this build typically takes around 10 minutes. OpenCV is a pretty large project, so I'll go ahead and skip to the end of this. Okay, now that our build has succeeded, let's go ahead and see what sort of tests have been discovered. I'll open up our Test Explorer, and it looks like there's around 12,000 tests that have been discovered, but we'll just go ahead and go into this test hierarchy here and navigate to just one of these tests, this conv/0 test. And straight from the Test Explorer, as you would expect, you can right-click and run this test. And you can also double-click on a test to take you right to that source code. Alright, it looks like our test failed, so let's scroll through this test and see if we can figure out what went wrong. Looks like right here we have expect near, and if I hover over that macro, I can actually see it expanded in Quick Info. But it's taking two values and it has some error term here, so it looks like we're checking to see if flops and declared flops are within some margin. If I hover flops, I can see it's of type int64, and declared flops is int, so that could be a problem. So let me go ahead and go to definition on that. And I'll change this to be int64. And then also, when I'm scrolling down here, I want to point out one more thing. You can see we have lp.blobs and we've put weights onto it. And then I'm checking if there's a bias. I then generate that bias, but I don't do anything with it. And so I want to actually push back the bias onto blobs, sort of like I did on line 628. So let me start typing out some code, and I'll hit this dot. And now you'll see that we're actually getting some IntelliCode suggestions here. So IntelliCode is a AI-assisted member list for us, and it's letting me know that it thinks I want to use pushback in this context that I'm in. And that's exactly what I do want to use. So let me go ahead and push back that bias. And I want to show that IntelliCode actually is context aware. So if I were to type the same thing, but do it within an if statement, so I type out lp.blobs dot again, now instead of recommending pushback, it's suggesting that I use size. And the reason for this is that it's taking in the context of the fact that I just pushed back something onto blobs and now I'm in an if statement. So it makes sense that I would maybe want to do something like see if the size is now greater than some number, for example. But let's go ahead and remove that extra bit. And with these changes, this test will pass, but instead of running it in the Test Explorer, let's actually run the exe itself for the associated target. So I'll scroll down, perf DNND, which is what we have in the Test Explorer, and let's run this target. And now keep in mind that this debug session is really happening in my code space, so I'm not using my local compute to do this debugging. You'll notice that we've hit our breakpoint and this console is being rendered on my local machine. You can see this cursor sort of following around my cursor, and that's because this console is being app casted from my code space to my local machine during this debugging. So we can see I've hit the breakpoint, and if I go over here, we have our locals window. We can see, for example, that declared flops is now this new type that I've given it. We have our call stack window and the other debugging tooling that you're used to having. So let me go ahead and click continue, and I'll open up that app casted version, and you can see the test has passed. This is that const/0 test, and the console output is letting me know that the test has in fact passed. So now I'll go ahead and stop the debugging. I hope you see the power of these fully managed environments that you can access from anywhere. All of the Visual Studio support for Codespaces is available in private preview, which you can sign up for at aka.ms/vsfutures-signup, and make sure on this page that you check the box for Visual Studio support for Visual Studio Codespaces. I really hope you consider signing up for this private preview, because right now we support console app and library development for C++, but your feedback will guide us and will help us decide what direction we go. And speaking of possible directions we can go, there's actually a couple more things that I do want to show you all. They won't be in the private preview, but I did want to share them just to show you possibilities that we have with Codespaces. So earlier I ran a build, and that's what I'm showing here. I'm building all of OpenCV, and I talked about how because I'm connected to my Codespace, all of that compute is happening in my Codespace, so my local machine is really freed up so I can do other things during that build. But what I want to show you now is a direction that we could go because of Codespaces. Because we're already in the cloud and using cloud compute, why not take advantage of these extra cores and do some caching and accelerate our builds? And so that's what I'm showing in this build that I've just started up above. Someone on my team has already built OpenCV, so even though this is my first time building it, I can take advantage of that cache and greatly accelerate my build. So you can see I'm already at step 940, and below, on the build that I started even earlier, it's still only around step 490 right now. So I've greatly accelerated my build because of the power of Codespaces. I'm able to do that build acceleration, and with faster builds, I can become more productive. The last extra feature I want to show is what we could do with Codespaces for targeting Linux. You'll see up in the top that I'm in an x64 debug configuration, so I'm doing some Windows development, and maybe I include windows.h, which is a Windows-specific header. Now, I don't get a red squiggle, but you'll notice, as you would expect, I get a purple squiggle here, which is the same as if you're using our cross-platform support for Visual Studio right now. And that's because Visual Studio knows about my Linux configuration, and it knows that that would be an error if I had switched to that configuration. So I can address this by doing an if-def, and then an if, and go ahead and just paste that in between, and now there's no more squiggle. So you could do that without Codespaces, but you would have to set up and configure and manage that Linux environment. But with Codespaces, this Linux environment is just spun up as part of my Codespace with one click, and I'm able to run this build. You can see it's copying the files to that remote machine. And down here towards the bottom, we can see it finished copying the files. We see that Linux directory. And down here, we see our build has succeeded and I successfully targeted Linux in my Codespace. All right, let's recap some of the values of Visual Studio Codespaces. These are managed development environments, and they're powered by the cloud. So even if you're on an underpowered laptop working from home, for example, you can connect to your Codespace and immediately become more productive. They also have easy onboarding. Just point it to your Git repository, and then you don't even have to worry about getting these SDKs and things on your local machine. That's all in your Codespace. Lastly, they have anywhere access. So because these Codespaces are in the cloud, You can connect to them from Visual Studio, like I showed, VS Code, or even from the editor in the browser, which I have an image of on this slide. I also showed a few forward-looking things that demonstrate the power of Codespaces and the potential that it has. I showed Linux targeting, where we saw I had my Windows and my Linux environment spun up in my Codespace. And I also showed build acceleration, where you can take advantage of these extra cores in the cloud. If you think Visual Studio Codespaces is something that you're interested in, definitely sign up for the private preview. I've got a link for that pasted on this slide, so you can go ahead and take a screenshot of this. Speaking of links, here's a whole extra page of links for you to screenshot. I have a link for our Visual Studio preview. You can sign up for the Visual Studio Codespaces private preview. I also have a link here for our developer community where you can give us feedback and suggestions. And lastly, stay connected with us by following our blog and following us on Twitter. Thanks so much.